All right, we are continuing Chapter 17, Section 2. This is lecture part 2 of 2. Part 1 was on concave mirrors. Part 2 is going to be on convex mirrors. So what's the difference between a convex and concave mirror? Remember, a concave mirror, the edges bowed out towards the observer. So this was our excuse me. This was our concave mirror. A convex mirror, the edges are going to bow away from the observer. So a convex mirror is going to look like this. Now when we do a convex mirror, let's draw a couple lines here. If we have a light ray that hits the center of the mirror, where's that going to go? It's going to come off right back. But how about one above? It hits here, it's going to kick up at an angle like this. And we have one like this. It's going to kick down at an angle like this. And what we get is, and this is important with convex mirrors, that the light rays are diverging. Right? So the light rays are diverging. In a convex mirror, the light rays diverge. What this does is it causes our image to be virtual. Where is our image? Well, our image is upright, but it's smaller. So our image in all convex mirrors are upright, smaller, and virtual, no matter where the image is. So unlike yesterday when we talked about concave mirrors, and the image, the distance of the object changed what the image looked like, that's not the case at all for convex mirrors. The image will always be virtual, upright, and smaller. Where do we find convex mirrors? Smaller mirrors that give us wide perspective. You might see these in convenience stores or in cars. The reason your passenger or driver's side mirror says object in this mirror closer than they appear is because it's a convex mirror. So just a little idea with a convex mirror. How do we draw a light ray diagram for a convex mirror? Well, I'll let you get your setup squared away. We're going to have our initial mirror, which is curved in the opposite direction. We are going to have our principal axis, our line going through the middle, which is our black dotted line. And then we are going to have our object. Now remember here, this is key. All objects are virtual, smaller, and upright. Let's get a little taste of how that's going to look. First things first, I'm going to extend my virtual line through the back side of my mirror. And then let's do a light ray diagram. Remember, what is the very first line that we do? Correct. We always go off the bottom of the arrow. I'm going to do that one in yellow. It goes off the middle. It hits the middle of the mirror, and what happens? It comes right back. Now, if this were to continue traveling kind of through the mirror in a virtual image, the light ray would continue to make our bottom of the arrow straight through. Same type of idea is that the bottom of the image will always be on the principal axis that cuts through the middle. Next up, we're going to do two lines. And these two lines are going to vary a little differently because the focal point for a convex mirror is behind the mirror. So what's going to happen a little differently is this. Our first line I'm going to do in green. And what would happen is it's going to hit the mirror. But where is that line going to go? That line is going to kick up like this. All right. Next up, what we're going to do is going to do another line in red. I'm going to do off the top of the mirror, off the top of the arrow to the center of the mirror. Now that is remember the center of the mirror is flat, so that is a flat mirror that will follow the rule of, or the law of the angle of reflection equals the angle of incidence, so it will come off like this. Now, what are we going to do? We have to retrace our steps. We are going to have to take this green and extend it out backwards like this. My diagram's not the best. Sorry, my mirror is too large. Extend it like this. And let's extend my red line out backwards like this. Where's my new object? It's behind the mirror. it's upright, and it's smaller. So what we're doing real quickly here is we have two lines. We have, again, our green line that goes to the mirror and bounces up. And then we have our red line, our second line, which goes from the top of the arrow to the center of the mirror and would bounce back down. Now, how do we figure out where our images meet? We are going to retrace them and have them extend beyond the mirror. Now, a couple things with convex mirrors which are very crucial and important. First and foremost, since our focal point is behind the mirror, the focal length is negative. So if you need to highlight that, the focal length is negative. Which leads us to, when we're doing a problem with the convex mirrors, we have to remind ourselves that the focal length and if it gives us the distance of the image are both negative because they are behind the mirror. Anytime the distance is negative or the focal length is negative, tells you that it's behind the mirror. So if we look at this very first problem here, a convex mirror in a warehouse has a 0.5 centimeter focal length. Well, our focal length is going to equal negative 0.50. A 2-meter forklift is 5 meters from the mirror. So our object distance is 5.0 meters. And our height of the object, our actual forklift, is 2.0 meters. What are the image position and image height? So we are trying to solve for DI and DO. Same equation that we've done before. 1 over F is equal to 1 over DI plus 1 over DO. 1 over negative 0.50 is equal to 1 over DI plus 1 over DO. DO is 5.0. We solve for DI, and what we end up getting is negative 0.45 centimeters. And we know it has to be negative. It's a convex mirror, so our image is going to be on the mirror, which makes sense, which is negative. Step 2 then is asking for the height of the image. Well, remember, HI divided by HO equals negative DI over DO. We're going to plug in numbers and cross multiply. We're solving for HI. HO was 2.0 meters, or what will go as 200 centimeters. We're doing a ratio, so we want to make sure everything is in the same unit, which I just realized we'll correct the last problem here. I just screwed up the last problem. Darn it! Our focal length was negative 0.5 centimeters. Our distance of our object is 5 meters or 500 millimeters or centimeters. So let's go ahead and fix that. 500 centimeters. So when we do this, this is going to change. Our DI is going to change. So just a reminder, it doesn't matter what your unit is, as long as they're all the same. So I'm going to use centimeters. So if we go ahead and solve this again, I end up solving for it, and we end up getting negative 0.4995, which is really close to negative 0.45, but we'll leave it at 0.5 centimeters. So we're going to use our magnification, HI over HO, plug and chug again. HI divided by 200 is equal to negative DI, which a negative of a negative is a positive, so 0.499 divided by our DO. And our DO is going to be 500. So we plug and chug, and in the mirror, in the mirror, the forklift appears to be 0.2900 or 0.20 centimeters tall, which means hypothetically, poor example, that you can barely see it in the mirror, but that's a good example. So just the key thing here is don't make the same mistake that I just made in regards to make sure all your units are the same. So if you have meters and centimeters, make sure you have both in play. If they're both are in play, make sure you're using one. And then secondly, make sure that if it's a convex mirror, your focal length is negative. Now, one chart here that is good to remember is kind of a little code here. We have plane, concave, convex mirrors. Something to review for each of those depending where the object is. In a plane mirror, it doesn't matter where the object is, everything's the same. In a convex mirror, it doesn't matter where the object is, everything's the same. The only place that matters where the object is a concave mirror. So we have 3 points here, twice the focal length, in between twice the focal length and the focal length, and inside the focal length. If you need to review that, you can go back to part 1 and summarize concave mirrors, but this chart does a really good job of summarizing everything to do with mirrors in chapter 17.